Hello everyone, it's me, long time no see. I know it's been a long time since I posted any videos. Apologies, it's been my life basically, a lot of stuff happening in there. Some people know, some people don't, but been looking at my dad, that's what kind of took me back. It's not my technical ability, it's just been a very busy time for me, and now things are easing off, so I think I'm having more time to kind of make more videos and focus on the real thing or the project that I wanted to focus on. So I've been working, as you might already know, since probably October, slightly earlier maybe, on a project. And basically that project is to come up with, call it a dream or an audio instrument, and or maybe to help others to make an audio instrument basically. So today, well, I basically in the past shared some videos on a glimpse of it. So I shared some video on the audio chipsets, shared some videos on other bits and pieces, but I think today we're going to slightly zoom into that and then explain what's happening in that on that front. So first things first, today making this video because today, just a credit to JLC. JLCPCB has been with me in the past for a long time, and even though they're not sponsoring this video, but it is credit to them. Great service, great care, love the work they do, love the support they provide me over time. I actually really like it. And today is the PCB engineering storytell. So basically I'm just going to share that information with you as well. First things first, without further ado. So I got my package delivered, which is a JLC PCB. Plus I have also the JLC PCB stencil. So this is now the beginning of my work, of my journey to show you. Let's just stop talking. Right, so I open up the box, and as you can see, nicely packed, beautifully arrived in one piece. Not a scratch on them, beautiful. And yeah, so basically here I've got, just going to take one of the boards out. There's 10 in here basically, and those 10 are a blank material, and you can see that there. So this is the board we talked about earlier. The OMAP is going to be sitting here. That's a 400 pin roughly in here, and you got the memory, the SD-RAM in here, and you got the what do you call it? The the flash memory in here. You also have 5 USB ports. You got the power supply there. You got 2 MIDI in and out in here. You got the audio connections in and out. This is that's going to be 2 jacks, and you got here 4 audio IOs as well for so audio in for the RCA, and you've got another audio in and out for the AIC 3106. You've got a mode selector, so you can select between I2S, I2C, TDM mode, all that kind of stuff in here. I'll come to that in a second. Also, you can have a 2 mode selection for the input and for the output in here. So I'll walk you through the circuit that was being designed. You got more input IOs on the audio side, and in here you have a what's it called, an SD card. You can obviously put in and out stuff. So this is basically the essence of it. So I haven't started placing any components yet, and I've got 20 of those, so 10 of this is going to be for me to do bug testing and finding out what's happening on that front, and another 10 currently being produced, and we're negotiating things on the components to put in there. Things like a couple of obsolete things, and then I go back into haggling between replacing with which right part, that sort of thing. So JLC, you pay additional extra $10 for them, and they do that for you. They're beautiful. it really is worth every single penny, to be honest with you. So that's the board, and this board basically is why we're doing this board is mainly to replace, or to, let's just say, add, not replace, any enhancement or additional stuff used for your music instrument or some music instrument. So basically you'll be able to can hook this up. It should have its own processor, dual or triple processors in here. I'll explain that in a minute. And it's got all the audio chipsets you need. It's got the old stuff and the new stuff, and it's a beautiful kit. So that's going to be available on Amazon once I kind of finished with it. I got the equipment coming up so I've got currently already purchased a solder paste machine that's already there and behind me. I'm gonna walk you through it in a minute, and also have a pick and place machine to place the parts on and off, back and forth. So just want to walk you quickly through. And the thing is, engineering wise, this is a beautiful, absolutely love the way they've done it from JLC, and I've tested a few parts of it. Beautiful, absolutely nice. Thank you, JLC. Love the work you did. Now just walking you through the stuff in here. So if I just take it to the 3D view, that's how the board should look like. And just quickly trying to glance on that at some point. Just waiting for that to kind of refresh. There we go. So now we have two MIDI ports on that side. You've got the selector mode. You've got the audio IOs. You've got the RCAs. These are the mode selection boxes, and that's a rotary switch, which is an encoder. So in case you want to twist and then press the button to change whatever things on the screen. You've got 4 RGB LEDs, which is the WS210, I think. These are for RGB kind of LED signals. The 4 USBs, as you can see here. I actually still not opened up to USB-C yet. I know it's a bit old-fashioned. I love the USB micro. It's kind of worked nicely for me in the past, and I like to stick to that a bit. You got the thingy port in here, the power. And you can see the OMAP is there, the flash memory and the SD-RAM. And it's all pretty much, comes up nicely on the board. And that's the memory stick over here. You can see in the back, just down there. Yeah, so that bit here. So that is an overview of the stuff. So this is, as I said, the engineering team. And I also want to say a highs and hoes and a quick shout out to my friends, Snakehead and Niall Warp, sorry. Best friends ever, and we used to be partners in the past in a business earlier. But love you all, guys, and really nice to hear from you, and love your support. So thank you so much. So now moving on, basically here, so I'm just going to close that. Let's just move on to the screen. And what is happening on that side? Why is this a big deal? Because if you look into the audio section, so this is the whole power design there. You've got the whole main thing. I already touched on that in the past. I did, showcase it and, kind of talked about it earlier. But I think the most thing we haven't talked about is the audio side. What's happening on the audio side? So why we have what we have at the moment. So let me just take a step back. Just give me 2 seconds there. Right, so you might ask yourself, or ask me, or ask basically. This is a Texas Instrument OMAP development board, or EVM it's called, the TMS320 6748. So you've got the OMAP in here. You've got a video chip, you've got an audio chip, and you've got SD-RAM, you've got memory. You've got this stuff in here, all of it there, nicely set up and stuff. But I used it in the past. It is a very nice kit. I loved it, and I did make some, few videos on it. As I said, it's a beautiful kit. What's missing on that thing? Unfortunately, it is not expandable. And what I mean by that is, when you try to, obviously, the only way to get this to work is to connect it to your debugger or the JTAG debugger basically. And then when you try to upload something to it, you upload and you have to trust that actually it is working in the back. So for instance, the OMAP has something called the MACASP, which is call it an intermediary kind of CPU inside the OMAP's head. It will say, I'll take care of the audio stuff. I'm going to be talking to the audio chipset, the one you have, and I'll be sending stuff and then, retrieving stuff via DMA. And, that sort of thing is you have to trust it to say, is it working, is it not? I don't know. I mean, I'm not getting the signal in or signal out. What is the problem? Don't know. It could be the OMAP, could be the TMS, it could be the port. So to debug that, it is not easy because the OMAP, as you can see, is a BGA, and BGA thing has got the pins underneath. So you can't really tap anything to the OMAP itself. It's hard, it's impossible. So I have to take it out and do stuff with it. And on the audio side, yes, I know where the audio pin is, but unfortunately it is really hard. It's impossible to actually do that stuff. So the only way to get this to debug or to find out is the MACASP sending signal out is to take the audio chip out and then do stuff and then put the chip back in, which is really inconvenient, and it's a kind of a big bummer really. So as I said, I love this device. I love the way it works, but the problem is the limitation. The second bit is, and this is the most critical part, is as I said, it's limited. I cannot tap. I mean, I did a video in the past where I hooked up Arduino to it, but at the end of the day, from the 400 pins you have on the system, you can only access about 3 or 4, maybe 10 tops, which isn't really enough. I mean, it's you got a Mercedes or a BMW kind of, or Ferrari kind of stuff, but you can't touch it because it's all fully integrated. It's so integrated deeply that you can't do much with it. So unlike the other world, which is the Arduino side or even the ESP32 side, you have all the pins outside. So the Arduino, you have the the setup pin sitting outside, and you can tap into any pin you like. You can draw a light, draw a signal, run a motor, all sorts of stuff, because all the header pins are exposed, and you can just put pins in there and do stuff. So that's what that limited is. Even though I love it, but it's it's limited. So that's the reason why I went into this design. So what does that have? This have one audio chip called the AIC3106. Now the 3106, to maintain compatibility with this device, I have decided to put the AIC3106 in my design as well. So in my design, I have the AIC3106 in here, and I pretty much have all the IOs working. Unlike this one, I only have 1 or 2 IOs, which is the mic and the line connection. I have all the IOs kind of hooked up and connected, and you can actually do stuff with it. Now, the AIC is unlike other chipsets. The AIC, you need to program it, you need to run some commands and then do stuff to say, set the baud rate, or set the what's it called, the audio levels, or the microphone, or everything is programmatic. So the OMAP has to tell it how to actually start responding, which is an interesting thing, which usually this would be an ideal thing for a PC, because you can configure the volume, you can configure the mixer and all that kind of stuff via software controlled PC. But what we need in this design is a kind of a device that says, I'm going to hardwire it this way, send you the stuff, and then that's it. You act as an audio. Don't ask me any question. I'm not interested. Do your job as an audio chip, and then move on this way. So that is how this whole thing is. So AIC is now put it there for the compatibility mode, and for the latest and greatest stuff, I have actually included the TAD 5242 Ergo, which is the latest and greatest from Texas Instruments. This is an audio chip, and as you can see, it's got 4 output ports. This is a DAC, digital to analog converter, DAC. And what happens is we would use the pins in here, and notice that's the whole point. Notice in here, I'm actually not connecting that directly to the OMAP. I'm actually leaving it as a header. So the header in here is what we're going to connect the OMAP pin to the header pin and then drive it this way. It is a much thing to do because now you can tap in your oscilloscope to this and say, do I have a B clock or an F signal or D in or D out, whatever it is. So that here is a really good design because you can say, actually, I want to do without it or power it up. And the more even beautiful thing in here, that chip can be daisy chained. And what that means is, as I'm pumping data in, I've got a little connection here, the pink one, which goes to the second chip, and that kind of give it a power up. That is something called TDM, which is time division mode. So that means is if I have a 1 minute packet, and I would say the first 10 seconds is channel 1, the second 10 seconds is channel 2, etc. I can have, stack up as many chips as I want. Obviously, there's a limit, obviously, but I can stack up so many chips. So if I put 2 in there, you can see now I have 8 audio out channels, which is a brilliant thing. I can go 16, but I think let's just not overkill it. I think that's enough. It's really good. It does the job. And on the audio inside, you can see here, similar thing, but this is the TAA 5242, which is also the latest and greatest. Same concept, exactly the same. So here you have the 4 input channels in 2 minus and plus, and then you got the daisy chain wire between them, and you can actually choose whether to do that or not. So all these things are powered by TDM'd, and you can choose to say in or out or power up both, that sort of thing. So now that's the latest and greatest stuff. However, to maintain compatibility with the old stuff, or this is the main thing I'm actually created this whole project for, is to tackle this guy here. So this is the PCM1793DBR. This chip is used by some music instruments, and basically if I would to put the firmware on that on my new design, and that firmware is talking to this chip, then that chip should work absolutely fine. Even though there are newer ones, there are better ones, but I just wanted to have that there. Not only that, I've also done, so this is a DAC as well. That's an output chip. And on the other side, I also have a similar setup for the 1802. Now, that is absolutely fine. It also to maintain compatibility on all the hardware in case we want to power up some firmware in here somewhere. Perfect. So that is what I wanted. It might not make sense in this video. Am I using a couple of old chips in there? But in later videos, a lot will make sense, hopefully. I could use the 1862, which is the latest one. Have more output, or 1864 with more output. Sorry, but I think I want to stick to what I have in mind. So I'm keeping that there. If you want to do the latest and greatest, by all means, go back to the 5242s, and they should be absolutely fine. MIDI-wise, obviously, it's a very basic, simple circuit. I've got the isolator, the optocoupler in here to isolate the incoming signal so it doesn't burn the chip out. It does it all here and then carries on and then fires the thingy out. What you also might have noticed is the MIDI RX and the MIDI TX actually are mapped into a what do you call it, a header pin as well. So here you hook up the RX and TX into, you put a wire like Arduino between the TX RX of the MIDI into the OMAP chip. And that's exactly what I wanted to do, because I wanted this to be completely configurable. And that's the beauty of this design. I love that bit. So now we have a main processor with memory, with all sorts of stuff happening inside. We have the audio side, and looking at the header pins, it'll kind of might make sense here. So the header pins in here basically are the pins that would make it look like an Arduino card. So this was the whole point of this design. Now, that you can't use as an Arduino card because, as I said, is limited. You can't do a lot of IOs with it because there's no room to put stuff in there. It's not designed like that. Which is these are the EMIF and the LCD, which is okay, but it doesn't really do what I really was hoping to do. So going back into my design in here, so this will be so useful, and it will look at the end of the day like an Arduino card. So just going to get the card back in here now, and as you can see those in here. So you got an Arduino, you've got only 2 of those, but in here you got almost 20. These I didn't do the whole full set because these are reserved to go to either the flash or the memory itself. So I don't want to, if I draw them here, they will have problems with the clocking when you need to do differential pair routing. So I actually took it off here, put it down there, and that's it, done. And this is part of the thing that actually left in there. So it works fine. Now, in some music instrument, you might see it's that uses the OMAP. That the OMAP is there. You got a PC talking to it and then telling it stuff, and then that whole OMAP is doing the stuff. Why is that happening? Or why don't you use Arduino, you might ask? Well, Arduino is a 16 megahertz CPU or processor, and that 16 megahertz is nowhere near enough to do stuff like power up audio and things. The reason, because yes, the brain of it runs at 16 megahertz, but the pins itself cannot go at 24 megahertz. It's just not hard. It's a bit hard for it to do. You can do the overclocking, you can do stuff like that, but it's not going to go as smooth as the OMAP. The OMAP does it standing on its head. So that's one part. The other part is, as I said, the speed of so OMAP can talk 24 megahertz with the audio chip. So the audio chip itself runs minimum at 24 megahertz. I mean, you can run it smaller frequency, but the general side of it is that you would usually power it with 24 megahertz clock, which is what we have on the board as well. So you need 24 megahertz clock, you need 24 megahertz speed, and Arduino is incapable of that. You might think, actually, but we do have now the ESP32. Yes, you do, but ESP32, although it's 240 megahertz and some of it is 300 megahertz, however, the pin's still a problem. You cannot get the pin to go as fast as you like it to go, as is, unless you do stuff with it, and it's documented. It's actually official. It's not an easy thing to do. So Texas Instrument OMAP is for me, is the winner here. It works and it does the job absolutely beautifully. So now what that means is the chip in here, what's going to happen is it's going to receive, it's going to say, get a nudge. Let's say a PC will say, play me sound. The OMAP will have all this, huge DSP algorithms, lots of stuff, blah, blah, blah. And it will talk to the audio chip, say, here's the signal, go and output audio, please. And that's how the whole thing will work. So the OMAP will talk 24 megahertz to the chip, but inside the OMAP is running DSP at 300 megahertz, which is about 6 times or maybe more times faster than the audio part. Now, the final nail in the coffin in here, what happens is you've got an OMAP talking to n number of audio chips. You can power up all of them, you can power up some of them. That's up to you, really. I'll give you that configuration. You can enable and disable is on the board as well. Everything is actually here. Now, the main thing is when you run the chips at that speed and the chip's actually functioning, the chip is not, let's just say, if you write a very good intelligent program that actually sits on the OMAP, inside the OMAP head or on the flash of the OMAP, that tells the OMAP to start talking, generate a sine wave or a cosine wave. That's easy. It'll give you the tone, it'll give you the output, absolutely fine. But once you start to get more complex, you need someone else to drive the OMAP to say, can you please do 16 channels. Channel 1 is sine wave, channel 2 is a audio sample, whatever it is, and all that stuff gets mixed up and then put into the audio chip. So you need someone to drive the OMAP itself. Now, in some instruments, you got another master, call it the PC, or another circuitry that push it out. On this device, on this design, which I haven't talked about yet, is the nice thing, I have also included an ESP32S3 chip, or a whole card basically here with all the debugging and all the bells and whistles with it. What that means is you can actually hook up these connections to one of the OMAP pins in here, and that will drive the OMAP. So you got this guy running at between 240 to 300 megahertz, using even I2C or any bus to say to the OMAP, I'm actually going to drive you. All you have to do is generate my sound. So this one does, give that a kick, and this guy starts to generate the sound. So you got your whole audio instrument basically sitting down here. This chip, the beauty of it is the latest and greatest from ESP, and it's got obviously Wi-Fi, it's got Bluetooth, it's got all sorts of things, and you can also hook up LCD if you wanted to it. Even though this guy does LCD by itself beautifully, no problem with that. But as a whole design, one day you might be able to replace the contents of your audio instrument with something like this, or with that in particular. And what that will offer to you, or offer at the end of the day, is a way of running any open source code. So the idea behind this now is I will make, this is going to be available on Amazon once it's, all the chips actually placed on it. So part one, as I said earlier, is going to be me testing and debugging stuff, and then part two, which currently is being done by JLC at the moment, JLCPCB, they are literally, as we speak, placing the parts and the components on that board as we speak. So that's going to happen, and I'm going to get another. It costs a lot of money, not really concerned or bothered with that, but I want to see my baby kind of working. So going back to the purpose behind designing this thing, this is going to run an open source code that I will start. I'll call it starting the ripple effect if you like. I will start leading that, create an open source, and it's going to be an open source to, well, anyone can contribute or like to contribute, more welcome. It's going to be free, no charge, but the board itself I'm going to have to sell because I have to make some money from it. But at the end of the day, it is going to be available as an open source, and you're no longer going to be at the mercy of an audio company. What that means is you got some instrument, some updates taken 10 years and nothing happened. Some wish list has been going for 10 years, nothing happened. You've got, some things got discontinued and then put back to the thing. They added someone, quite funny this one. The instrument came back to life, I think a few months ago. But the trade-off is, it is the same thing. They just added a couple of 200 sounds or 100 sounds, whatever that is, and they're trying to sell it to you. So is it worth selling and buying? And I'm definitely not. So you're at the mercy of these guys, and I'm basically trying to do something to kind of give you the freedom that you're going to run today, or sorry, not today, one day, you're going to run your own instrument, your own sound, your own stuff that you'd always dreamed of. No licensing, nothing. You just have the board, run it, and you got your audio instrument. All you have to do is kind of be a little patient with the open source stuff that I'm actually working on now. But it's happening, as you can see. The design is here, the board is there, and I will not stop until this thing goes live. So it's going to be a bumpy road to begin with. Obviously, we'll have teething problems. We'll have some stuff to kind of tackle. But at the end of the day, it's happening. I do hope that kind of, give some people hope or put a smile on your face, let's say. It is something I started working on. But again, I have been busy and still am. I have to look at my father, and it's taken a long time for me to kind of, focus on this or doing the videos, or also on top of all this, I'm actually doing a 9-to-5 job as we speak. So it's not easy for me to find the time, but it is happening. It is happening, believe me. Now, Part of this video, I had to kind of re-record or record additional to it, is because of what JLC have in regards to the open source engineer stories. Now, I am personally a big fan of JLC, JLCPCB in particular. You can see the website they have in front of me here. I love their work, as I said, and at the time I had to kind of double check my figures just to say, is it the right thing to do, JLC, or shall I try PCBWAY? So I've got PCBWAY in here and I've got JLC. So I just wanted to share my own experience, why, and by the way, no one is paying me to say this, but I just wanted to share in essence, what is the difference from my engineering perspective? Why did I choose JLC and not PCB? So in JLC, if I click on order now, and you can see the add Gerber file in here. The button is so big, it's in your face, you can see it straight away, and then you can say, actually, I'm going to click it, and then upload my, sorry, not videos, upload my design. So I'm going to go into the OMAP test, and I'm going to go to my version, the latest version. Sorry, 1 second, yeah. And I'm going to update my latest version, and I'm going to pick the Gerber file in here, and it's uploading, right? And notice in here, it's all the parameters, the 100 mil, whatever it is, and the number of layers in the board and the colors. All that stuff, or most of that stuff, all the relevant to the board, is going to be uploaded. Without asking me more questions, the only questions I have to choose in that side is, what color do I like the board to be, and how advanced it is, and the diameter hole to drill, that sort of thing. So it is a great service. It takes another 10 seconds or maybe less to get this whole thing done, but it's from a convenience perspective, the JLC PCB has always worked beautifully for me. I just upload the Gerber file and then carry on from there. I'll just show you. There you go. So now you've got the board files in here, the top side, the bottom side, and I get to choose. So it's already picked up, it's 10 for me. It's already picked up the dimensions. The quantity is something I would actually do. These things you can obviously speak for themselves. It's not medical, it's not aerospace, it must be that. And different design, single PCB, or how do you want to do it, single or panel by. This is the panelized, where you actually have more parts added in one PCB. I don't need that now. You've got the thickness of the PCB. I can keep it to default, really. Black, that's what I liked. It cost a little bit more. And other stuff, pretty much most of the stuff in here are going to be default. I mean, the only thing I'm going to change is the drilling hole to 0.15 millimeter, which is a little bit more expensive, but because I'm using the OMAP in here, you can see there's 400 pins in here, and between each pin of those, see how tiny this is. This is like my thumb, or say my index finger is bigger than the chip. And between each pin and the other, there is a hole I actually drilled, and that's how we got 0.15 millimeter. I mean, you can see how accurate this is. It's unbelievable. See the chip in here? They're actually literally, you won't see it. There are 400 holes inside here. You won't have access to see anything there. That's how accurate this thing is. So anyway. Carrying on, so the interface is just user friendly. You can see, the screen. That's what I'm trying to say. Is there. You can only focus on the relevant stuff, and you got that blankiness in here. Beautiful. It's just you can focus on this. This is white. This is black. You can know what's ticked, what is unticked. What do I need to do things? And if something you don't know, you just click on this question mark, and it'll explain to you how it does, and the assembly. You click the stencil, and the stencil comes in. It's really simple. You just click, and then at the end of the day, you just go to save to cart and order now. That's how simple in JLC. It works really beautifully, and also notice one thing. It did automatically select advanced PCB, because I think usually because I'm drilling the hole size as 0.15 millimeter. However, in PCBWAY, and that's the part I did not like. Notice in here, it is loads of information here, tons of stuff. The screen is full of stuff. I don't know where to start. If that's not complicated enough, look at this. Where do I upload the Gerber file? Right? I don't know. And what's the difference between standard PCB or advanced PCB? What do I choose? So I mean, if PCBWAY is seeing this, have a look. I mean, guys, just, you know, it's for me, it just, I can never use this interface. It's so complicated. It's just so you know, intimidating, call it. And I don't know. The reason I say that, because, for example, I have to manually say if the board is this size or the board is that size, or whatever, and you know, and I don't really know, am I accurate or not? I mean, did I do a mistake? Is it, if I put down, for example, 200 or 300, am I going to end up with a board bigger than the PCB or smaller? So it's a bit of a risk, really. And then, you know, the layers. You know, it's up to you to choose the layers, which is, you know, why? Just take the Gerber file and then set the thing yourself. It's all in the Gerber file. So what if I made the mistake of 12? Right? Material. That is fine. FR4 is the standard these days. Thickness 1.6. Yeah, that is fine. Min stuff. I don't know what that. You know, the minimal track stuff. I don't know what that is, but I'll keep it as default. I don't know what that is. See, as a first time user to the system, there's a lot of parameters you have to set before you even consider uploading the Gerber file. So you hit with so many information to actually share, and for me that puts me off. I can never click next on this one. And that's the problem, right? So calculate, yeah, I mean, I could be calculating right to calculator, but anyway, just to save you time, I did go through the process. I did upload the stuff, and I managed to copy it from the JLC site to say my board is 143.7, so I take that down here, enter it down there, so 1.3, 143.7, whatever, and then do that there as well, and then calculate. And then I went through the process and then did the calculate button, and then the next page, then you upload the Gerber file, which is a backward process really. And then at the end you get sent an email saying, okay, yeah, we noticed you want to upload or do your parts as well. Let's calculate. They calculate and get back to you. And then they got back to me. I was hit with such a huge list of stuff to go through, and so at that time, so no, so I'm giving up really. I can't carry on. I did, you know, let PCBWAY let you know that you know, guys, this is a limitation. I'm giving you a constructive feedback. I know you're big. I know you got your audience or your target, and I'm sure lots of people love you. You know, for me, I decided to go back to JLC because that's how easy the process with them. And to be honest with you, I think JLC for me is the best. So thank you for JLCPCB. You know, and honestly, I couldn't do this without them, because it is such a great engineering work. It really is, and I absolutely love it to bits. So thanks again, and we'll stay in touch. Thank you.